Hey everybody, today we're going to talk about samples and surveys. When you're collecting data to solve a problem, or in other words, conducting a survey, you need to make sure that your methods are going to be fair and that you accurately represent your data. So in other words, you're not going to go to an ice cream shop to ask people whether they like ice cream or not, because most likely if they're at the ice cream shop, everybody's going to say that they like ice cream. So it wouldn't be a very good accurate representation of the data. Okay, when we are collecting our data, there's two different types of data that we can get from a survey. We can get quantitative data, which is going to be units that can be numerically compared. So your numeric data. Most of the time it's numeric data, such as ages, weights, and time. Something that we typically think of a numeric data would be something like jersey numbers. That is actually not quantitative data, though, because we can't really compare that numerically. Jersey numbers would not make sense to compare numerically, but ages, weights, and times would. Qualitative data, on the other hand, is just describing a category, and it can't actually be measured or numerically compared, such as hair color, altitudes, or attitudes, your zip codes, jersey numbers would actually fit underneath this one, favorite colors, those kind of things. Okay, so let's look at a couple examples here of qualitative versus quantitative data. Okay, if we look at the average number of visitors per day at each of 6 different theme parks. Well, if we're talking about the average number of visitors, this is numerical data, and we can actually compare it. So this is actually going to be quantitative. Okay, think of it as quantitative is describing a quantity of something. Okay, quantity, we usually typically think of numbers when we think of that. So that might be a way to help you remember that. Okay, monthly low temperatures in Rochester, New York. Okay, well, we can actually compare temperatures. We can find averages of temperatures. So this would also be quantitative. Okay, names of U.S. presidents in the states they were born in. Okay, these are just names. This is non-numerical data, so all we can do is figure out, compare it. It's qualitative data. Okay, qualitative, the base word is quantity or quality. So, I mean, you can think of the quality of something, and that's not numerical. Okay, favorite color in person's gender, this is non-numeric again, so qualitative. Okay, so that's quantitative versus qualitative data, non-numeric versus numeric data. Okay, when we conduct a survey, okay, we have our entire population that we can look at, but when that population is too large, we want to take just a sample of that population. So if we wanted to get a good idea of the heights, the average height in Bellevue East, it's going to take forever to sample 1,600 students. The 1,600 students would be our entire population, so we're probably going to end up just taking a sample of that population and only surveying, let's say, maybe 500 of the people at Bellevue East and taking the average of those 500 people. Okay, there are 3 different ways to actually to use a sampling method, so to pick a part of the population. Okay, our first way is to randomly sample people. Okay, this is exactly how it sounds. You're just going to randomly pick people as you're walking down the hall to ask the question to or to survey. A perfect example of this is to just draw names out of a hat to see who you're actually going to ask the question to. Systematic is the second way, and this is where you pick a random number, so 10, and you're going to survey every 10th person that you see in the hallway. And then our last one is stratified, and this is where you're going to separate your population into smaller groups such as freshmen, sophomores, juniors, and seniors, and then you're going to randomly select a certain amount of freshmen, sophomores, and juniors and seniors to survey. Okay, so we want to determine whether Our sampling method is random, systematic, or stratified, and we also want to tell whether it's going to produce a good sample. Now, on your test, when you have these questions, there is a right and wrong answer for whether it's random, systematic, or stratified, but when you tell me whether it's going to produce a good sample, I'm going to look at your justification and we'll go from there whether it's a good sample or not. Okay, so first one, a pollster randomly selects 100 people from each town in a certain candidate's district to see if they support the candidate. Okay, well, we're randomly selecting people, okay, so right away you might think that it's random, okay, but we're actually randomly selecting people from each town, okay, so it's actually broken up into smaller subgroups first by the towns and then randomly selected from each town. So this is actually going to be stratified. So this is similar to breaking it apart into freshmen, sophomores, juniors, seniors, and then randomly selecting 100 of those freshmen, 100 of those sophomores, and so on. Okay, next one, a factory tests the quality of every 30th shirt made. Okay, well, they picked a random number, 30, and they're testing every 30th shirt. So this would actually be systematic. Okay, and I would actually say that this is not a good method of sampling because when you are working on a factory line, if you're only testing every 30th shirt may come from the same line, so meaning every 30th shirt may be messed up or every 30th shirt may be good where every 29th shirt is bad. So systematic testing for a factory line would not be a good method of sampling. And for the first one we did there, stratified sampling for selecting 100 people from each town is probably a good method of sampling because if most likely 100 of the voters that you select are going to be registered, so it's going to be a good sample. Okay. The third one, a printing company randomly selects 10 of 450 books it printed to see if all the books were printed properly. Okay. This is going to be random because they just randomly selected the 10 books that they're going to print. And this would actually be a good sample because it's not saying they picked the first 10 or the last 10. It's just a random 10 books that were printed. Okay, and finally, you want to find out how many DVDs students at your school rented in a month. You interview every 10th teenager you see at the mall. What sampling method are you using? Okay, well, this is actually going to be systematic because it's every 10th. And this is not a good sample because if you want to survey students at your school, okay, you're probably going to survey at your school, not at the mall, okay, because people at the mall are not necessarily from your school. Aren't all from your school. Okay, so when you're determining whether it's a good sample or not, you have to think about all the scenarios that go along with it, such as you're surveying at the mall, but you want a sample of your school, which doesn't make sense. Okay, and that is stratified, systematic, and random sampling. Okay, for tomorrow, please create an example of systematic sampling. So come up with a scenario that would be systematic sampling. And we will see you tomorrow.